Welcome. Good afternoon. One question that I had was about the lab. Let me see here. Oh. Go to our section here. And what did I say about? Okay, so for lab 2, for last Friday, saved photos, sure. So what happened was a long time ago, I made these R labs and they were meant to be for Stat 121 and 124. But then it turned out that R was way too hard for them to learn, and no one wanted to teach them, so we kind of parking lotted them. And so now I use them sometimes because sometimes I just want everyone to be on the same page. And so for lab 2, what I did was I said, okay, lab 2 is a combination of 2 labs. So it's called chapter 1 and chapter 2. It's kind of discombobulated, but I think you'll see it when you open the instructions. Okay. And so their respective videos have been added to our playlist. But what I would suspect for you guys, especially because you've worked with R a little bit, presumably, you might find that reading just reading the instructions is enough, right? And that's fine. So for me, I only post the videos trying to explain the notes that I post. So don't feel like you have to watch the videos, right? Sometimes if you're fine just reading the instructions or reading the textbook or whatever, that's all you are required to do, right? And then I make videos to try to explain all the concepts and try to explain all the instructions, right? But if you can handle it, then you're good to just read them, right? And I think we've talked about this before, because I'm totally I prefer to just read. I don't like watching videos, but maybe I'm just weird. I don't know. And so my hope is that these exercises that I'm giving you, so there are exercises at the end of the instructions for both sections. And so hopefully these exercises are very easy for you, right? And if not, I'm trying to make sure that we all have the same basic knowledge before we go on into kind of deeper labs. Okay, and so one thing that I noticed was that the instructions say to knit to HTML, but I want you to knit to PDF. Okay, so just ignore the HTML mentions and just knit to PDF. Now, for kind of simplicity's sake, I want you to submit the exercises separately. Otherwise it's way too hard for me to kind of mark it. But the lab 2 chapter 1 submission, and if we click on these, well, I guess this is a screenshot, so I can't really click on it, but I'll go back there and click on it. So the chapter 1 submission and the chapter 2 submission. So I did decide to do a combination because they are really short. I think one video is a little bit longer than the other, but like I said, you don't have to watch the videos. They're just there if you need them. Okay. And all the components that you need are here as well. Okay, so let's go back here. And if I show you the instructions, right, we start in chapter 1. It's a hello world situation, which if you're unaware, hello world document is really just kind of a starting point just to show you some of the functionality if you're learning a new programming language, which we are, right? So we're doing a little hello world document, and and we've got some objectives, just kind of learning about, okay, what are some of the things that we need to know, right? How do I format my text, and how do I work with our code chunks? And so very basic stuff. And like I said, this should be very, very easy. But if it's not, it's okay. I'm kind of trying to build you up. Okay, and so the instructions are here, and like I said, some of it is, I read through it and it's all kind of basic stuff, but some of it might be a little bit outdated. There might be fancier ways to do stuff, but this stuff, these instructions will still work. Okay, I think I made these a long time ago, and then I haven't really gotten to use them. I think I got to use them for one term, and then the other instructors said, this is way too hard. I don't want to teach my students this. And I said, they can handle it, but they didn't want to. I think they didn't want to learn it. But anyways, so at the end of each chapter, there is a series of questions in the on your own section. Okay, and so some of them are not really questions. For example, make a new R code chunk and then you do a calculation in the R code chunk. So that's not really a question, but if you have an R code chunk, you did it. And I'm also pointing you towards data camp, where you know, if you want extra practice, then data camp is really cool, and they've got way better resources than I could put together alone, because they've got a whole team putting stuff together. So oh yeah, and then I have my funny, my code doesn't work and I have no idea why, and then my code works and I have no idea why. Both of those happen all the time. It's like, why did it work though? That's the most confusing one, is when it works but you thought it wouldn't. It's like, weird. And then chapter 2, so then I'm just showing you yeah, sorry, yeah, exactly, it's so true, it's crazy. And then importing data and just some very basic exploratory analysis, right? So exploratory data analysis, EDA, which we're going to keep talking about today. Okay, but just some core commands that you should have a good handle on, that you should rely on. And then at the end of this one, there are also on your own exercises that you can work through. Okay, and so those are the ones that you're going to hand in, the on your own exercises. And maybe I'll clarify here, submit the on your own exercises separately for chapter 1 and chapter 2. And so that's what those drop boxes are. Okay. And so that's what I wanted you to do for lab 2. I think you were just wrapping up lab 1, and it's a little bit discombobulated because we started with linear regression, and I just wanted to kind of basically wrap up Stat 230 because I felt like we didn't really get enough time to talk about it, but we'll come back to it later on. I can't remember what section it's in, but I got my textbook. It's so small. It's cute. It's got a crab on it. And what I'm slowly realizing is I think I told you guys to read chapter 1 and 2 for this week. And that was a little bit mean of me because I really don't think we're going to get past chapter 1 this week, and that's okay. Right. But I mean, eventually we're going to work through this entire textbook. So you may as well get to reading. And so what I want to do is I'll try to pull up a page where it has kind of the do I want to do? Okay, kind of hard to show, but in the textbook, well, I spent all that time finding a page that would work, and then it's hard to see. But for the labs moving forward, what I want to do is I basically want you to recreate the R code and the Python code that's in the textbook. Okay. And yes, that is available on GitHub. And I'm not asking you to recreate the wheel. I just want you to have it up and running. And so for the lab this week, we're going to start to recreate the R output and the Python output. I think the textbook only shows the R output, but then what I want you to do is I want you to also recreate the Python output, okay? And so nothing crazy. We're just really going to work through this textbook kind of in the most intense way, okay? And so for future labs, right, for the lab this week and ongoing, for the lab this week and moving forward, okay, we will be working through the code that's introduced in the textbook, right? Both the R code and the Python code, just so you know what's coming up ahead. So I'm not going to get crazy and create other labs. I think this will be exercise enough. And once you kind of get the hang of it, it's going to be relatively easy, but it's also really good to have that kind of code bank. And yes, the code is available on GitHub. You can just go download it, but I'm not expecting you to be able to do that or know how to do that, right? But that's also a skill, okay? And so, so that's what I want to kind of get set up for the lab this week. So for the lab this week and moving forward, we will be working through and recreating the R and Python code introduced in the textbook. Because what I find happens introduced in the textbook, because like what I find happens is when I read these textbooks and they have R code or some other code being introduced, I tend to skip it, because especially if I'm not coding and I'm not trying to recreate those things, I just take it at face value and I say, oh, okay, well, here's the output. And what I find is that's not always the case. They've done some tweaks that they don't show you. And then, so I want to kind of get down and dirty with that. Okay. One thing that's kind of different, I guess, is that you are allowed to work with other people. In fact, if you are working and collaborating with other people, it can be a big group, it can be a small group, whatever, then you just hand in one document on behalf of all of you. Now, there are issues with that, right? I hate working in groups, for example, because I end up doing all the work, and that's just how it is. And I'm sure a lot of you feel the same way, because that's why you're in this program and you're working hard and all that stuff. So, so if you want to work through it on your own, that's totally fine. It's totally doable. It's just that I don't want to see the same thing over and over and over again, because I am encouraging you to collaborate and work with each other and kind of work on those group skills, right? But I don't want to have instances where someone, two people have handed in the exact same thing, and then that's bad. But really it's not that bad because you're just working together. Anyways, to avoid that, just hand in one document with the same for both of you. Okay. And so for lab number 3 onward, you will be allowed to do group submissions. Okay. And so I'll talk more about that in the lab instructions, but you will be allowed to do group submissions. And, you know, like I said, it's totally reasonable to work alone and work through this on your own. But most of the time we're going to be working with other people. And so you may as well just submit one document and that's fine. So I'm not marking the same document 4 times over. It's really annoying. Yeah. Okay, so that's kind of where I envision these labs going, and that's how we're going to kind of start to use the textbook a lot more. And so I think just as an apology, it's a formal apology if I say apology. I asked you to read chapters 1 and 2 for this week, but honestly, we're just going to work through chapter 1. Okay, so I asked you to read chapters 1 and 2 for this week. But we will only make it through chapter 1. That's okay. Next week, we're going to do chapter 2. So it's totally fine. You're just working way ahead. And I am finding that, of course, reading the hard copy is a lot easier. And it's nice and big text. Anyways, thrilled to have my textbook finally. So I asked you to read chapters 1 and 2 for this week, but we will only make it through chapter 1. Sorry. Chapter 2 next week, though. Hey, this doesn't say sorry. It said Sorny. Chapter 2 next week, though. So my plan is to work through this textbook and also the code, which is easy to overlook, but I'll save that for the labs, because otherwise I find that I'm kind of spending most of the time switching screens and kind of typing out code, whereas that's not really the point. Okay, so we'll save the lectures for theory and the labs for actually doing stuff. And one thing that I want to just mention here is that the code is available on GitHub. And I'll make that part of the lab where I'll show you how to get it and how to use it and what you can do. And then you can start thinking about. And okay, so the group submissions can be different for each week. Okay. Not necessarily the same groups each week. Have you found my GitHub? It's ancient. I haven't been on there in forever. No, I don't think so. No, it's on the textbook GitHub. I think it's Peter Gedek has, there's a link. Where is it? You can search for, how do I add this here? GitHub, Gedek / practical statistics. And then it's the name of the textbook for data scientists. Sorry, I don't have the link on my iPad, but it's in the first few pages of the textbook too. Nice. What I do, because I'm kind of sheepish about working on GitHub, is I just download everything and I just steal everything. But I'll show you how to do it in the lab. Okay. So you're not typing out this code. That's insane. Okay. What can we do? What are we doing today? Oh yeah, I did my apology. We talked about the labs. We talked about the textbook. I'm excited to have it. We talked about last week's labs. So the reason I wanted you to do last week's labs is because that's some core knowledge that I'm expecting you to have, right? And so if it feels easy, it's supposed to be easy. If it feels hard, then you need to put in some work and make sure that it is easy, that it feels easy. Anything new is hard, but the more you work on it, the easier it gets. Okay. I have very little space at this desk. It's actually not even a desk. It's like a sideboard thing, very tiny. So I'm trying to figure out where all my papers are. Okay. Oh, thank you, Hussein. So Hussein just shared the real link, not my fake link. Thank you. Awesome. Okay, so for some review and just brief review from last week, I guess, we ended up talking about mostly measures of center. I'm trying to remember. Oh yeah, we introduced data, just kind of talked about data, talked about mostly the differences in terminology, right? What's the difference for a data scientist versus a statistician? And then we ended up on, so kind of data terminology. And we talked about measures of location, which we typically call measures of center. And so measures of location or center. So things like the mean, the median, not really the mode for numerical data. Measures of location / center, and I'll finish here for numerical data. We also introduced some measures of center that we didn't consider in Stat 230 that are going to be kind of coming up more and more now, like the trimmed mean. And we can do a weighted mean. What else did we talk about? The trim mean, the weighted mean. We can talk about percentiles. We can talk about the median, weighted median, that kind of thing. So here I'll just do a quick, the mean, the median, the trimmed, oops. Trimmed or weighted, and I should do trimmed mean, weighted mean, etc. Just kind of The only reason I'm doing it all cramped is because this is the page break and I want to keep my review on this page. How about I do this? Bump it up. Only to have my little end of review symbol there. Okay. So that's all from last week, and we're going to rely on the measures of center, but I also know that this is a review from Stat 230, except, you know, the trimmed mean, now we're kind of introducing more sophisticated concepts, whereas we basically stuck to the mean and the median. So what I want to talk about today mostly are estimates of variability. And make sure it says variability. Okay. So variability, we can also call it dispersion. Okay, so it's kind of a common word that we use instead of variability, but it's really just the spread of our data, right? And so, and the spread of our data is kind of why statistics exists, is because we're trying to tease out, okay, what is that normal, that usual variability? I shouldn't say normal, although it kind of works, but, right, because you know the normal distribution. But what is some expected variability? So what's that kind of real variability, and what are some of those kind of the variability that we need to tease out, that random variability that just kind of makes it hard to pinpoint exactly what an outcome is going to be. So so the estimates of variability, usually we talk about the variability as a measure of how far are data points from the center or from the location, right? And so usually, right, these values consider the distances of observations from the center, or what we're calling the location now. So consider the distances of the observations from the center or the location, right? I think I was saying this in my other class too. I don't know why, but sometimes my Apple Pencil acts like it's running out of ink. It's really frustrating. It makes no sense. I think it's when I hold on, I don't know what it is, but here it looks like I'm running out of ink. I'm gonna need to rewrite that. Location. Okay. Now there are many different ways that we could measure those distances. And so what we want to differentiate between is we want to, there's random variability, and then there's kind of real variability. And it's really hard to kind of distinguish between what we call the noise and the true variability. Okay, and so let's see here. In statistics, right? And that's always going to be my kind of comfort zone, right? As in statistics, this is what we do, and that's because that's where I come from. But now we're kind of talking, okay, well, that's kind of less important. The theory of how that's happening is less important than what we do with it, right? But we have to know some of the theory. That's just the mathematician in me. So in statistics, right, we focus on distinguishing, or trying to distinguish, I should say, because it's quite impossible, on trying to distinguish between real variability and random variability. Between real variability and random variability. Those feel similar, right? But that random variability is sometimes what we call the noise. Okay, so we can call that the noise if we want to, because the example that I kind of think about in my head is if we think about mosquitoes, right? We know that mosquitoes are kind of they're the same size-ish. But at the same time that we say that they're the same size, we also understand that they're not really the same size. They're not all exactly the same size, right? We expect very little variability, right? But then if we have some new breed of mosquitoes that are being introduced, for example, and they are typically larger, then is that real variability from the mosquitoes that we're used to seeing, right? Or is that just randomly larger mosquitoes, right? And so that would introduce this noise, right? And so so in statistics, our main focus is trying to kind of pull that apart and accounting for variability in our data, right? Because we understand that no measurement is going to be the exact same, but there's some variability that we expect to see, and then there's the noise that's kind of saying, oh, okay, well, these things look different. Are they truly different? Yeah. And so here, if we think about, so for example, consider, and I like to think about mosquitoes, and sometimes I'll talk about dog breeds and stuff like that, but dog breeds have a large variability. And so I want to focus on something that has small variability. And so let's think about mosquitoes, right? So consider the lengths of mosquitoes. Now it means I have to spell mosquitoes. Mosquitoes. Is there an E on there? I don't know. Yes, thank you. Okay. I've got personal spell check here. I'll do this. And then we're out of the woods. I don't know. Doesn't matter. I think we understand what we mean, right? And so we've got these little mosquitoes, and we all understand that, you know, mosquitoes are all typically this big. Yeah, I need my phone to tell me if it's right or wrong. It's okay. It's okay. Okay, and so we consider all mosquitoes to be the same length, right? But at the same time, we understand that there's this this random variability. They are not all the same size. We understand that, right? And so we would say all mosquitoes are the same length. With the understanding that they're not truly the same length, right? They have this random variability. With the understanding that they are not the exact same length. And that's what I would call the random variability, right? So there's this activity here, right? And so here, this is what I would call the random variability. Okay. So then what would real variability be? Well, real variability would be if we started to see a bigger fluctuation in the sizes, right? Is that fluctuation in the sizes, is it due to just the noise, right? Are these just random mosquitoes that we haven't seen before? Or is it because we've introduced a new type of mosquito potentially? Right? So is it truly a different type of mosquito, or is it just the same mosquitoes that have more noise, right? And so, and this idea is really, I find, very difficult to wrap your head around, especially when you're just learning this stuff. But that's all part of it. So we would say all mosquitoes are the same length, with the understanding that they're not the exact same length, right? And that would be the random variability. Whereas the real variability, if we think about it, is if we find an exceptionally large mosquito, then I'm not going to put any on there. I don't know. Right? Is that because it's from a different type of mosquito, right? Is it from a different type of mosquito? Or is it just a randomly selected large mosquito from the old group, right? Or is it just an extreme observation from the usual group of mosquitoes? From the usual group, of mosquitoes. Oops, there, I did it. No E. I should at least be consistent, right? I need to think of something other than mosquitoes, maybe ants. That I can spell. That's okay, we understand. Okay, so this idea came up when we talked about p-values, for example, right? What's the probability of seeing something as extreme or more extreme than what we saw, right? Assuming that the null hypothesis was true, that's our p-value, right? And so here, I don't want to get into p-values, right? But here, I want you to kind of think about p-values. That's what's so nice about you guys have seen stat 230 and we're kind of going back over the concepts, but now I can refer back to concepts that come later in the course, which we weren't able to do in stat 230, right? So for me, that's really fun. So think about p-values, which is the probability of seeing something as extreme or more extreme than what you saw, assuming the null hypothesis is true. Than what you saw, assuming the null hypothesis is true. The null hypothesis in this case would be this mosquito is from the original group, right? Our alternative hypothesis, what we think might be going on is, well, no, it came from a different group. It's more likely that it came from a different group, right? What's the probability of it coming from the original group? Well, that's the p-value. If it's small enough, then you would say, okay, well, it probably came from this other group. That's more likely, right? It's still possible that it came from the original group, right? Okay, but to get there, at the heart of all this is that variability. How much variation am I expecting to see, right? And so I'll say at the heart of all this, all this that we've talked about already, is the variability. Okay. And so there are some important measures of variability that we consider. And so we focus on the variance or the standard deviation, which is related to the variance, directly related to the variance. And so variability is typically a measure from the center. Now, remember, we have different measures of center, so it's not necessarily the mean, but it's usually the mean. And but we can have measures from the median. We can have measures of spread. We've called it before, from different measures of center, but we focus on the mean. And so the most common measures of variability are the variance, you can tell by the name, right, are the variance and the standard deviation. So the variance we denote by s squared, a lowercase s squared, because the lowercase s is the standard deviation, right? And so, and I'll write that down, but and so they're related, right? The variance is the standard deviation squared. And so what is this s squared? If we think about the formula, it's the sum from I equals 1 to n of xi minus x bar squared divided by n minus 1. I will make a note here that this n minus 1 has to do with the degrees of freedom. Oh, I guess I should write it out, even though you're familiar with the degrees of freedom. And it has to do with, we've already estimated x bar. Now, the textbook does have a little summary note on the degrees of freedom, but that's about as far as we're going to consider it. So I encourage you to read that. But if it doesn't make sense, it's okay. Just know that and we divide n minus 1 as to n. So if we think about the mean, I add up all the values and I divide by n, right? And so we would kind of expect the same thing for the variance, but then all of a sudden we use n minus 1. And the reason, the brief reason for that is because it gives us a better estimate than just dividing by n, right? And so here, n minus 1, or maybe I'll say dividing by n minus 1 n minus 1 improves our estimate of the variance because it is an estimate based off of our sample, right? And so dividing by n minus 1 improves the estimate over simply dividing by n. Okay. And I'll say see blurb in the textbook. Okay, because they do talk about it, and it is important to kind of have seen it, right? But it's not something I'm going to focus on. For us, this is the formula that we use for the variance, and that's it. Okay, and feels like a good multiple choice question, though, right? I don't know. Why do we use n-1 instead of n? Something like that. Okay, so and it has to do with a biased estimate versus an unbiased estimate. Anyways, it goes on and on and on, but those are some of the key reasons, or that's one of the reasons. It gives us an improved estimate is the reason that I'm going to stick with. Okay, so, but if we go back to the formula, right, then let me just copy this here. Copy. Because I want to just talk about it. Right, so notice a key component here is that from each of the observations of xi, x1, x2, x3, x4, x5, xn, all the way up to xn, right, is our whole sample, right? So from each of those, we subtract the mean, which means that we're taking the distance of each observation from the mean, right? So here we consider the distance of each observation, right, which is x1, x2, all the way up to xn. Oops, that should be an n. From the mean. Which is the location, right? So the variability is a measure of the distance from the location or the mean, or sorry, the center. The mean, right? So just to clarify, the distance from the location or the center. The only reason I keep saying location / center is because for me, it's really weird to call it the location. I'll get used to it eventually, and you will too. And at that point, I'll probably start just calling it the location. But for me, I just want to emphasize that it is the center. Okay. And so our most common center that we use is the mean. Okay. And so we're taking the distance of each of these points. And then what we do is, if we're adding all these up, right, we're summing all these up from 1 to n, right, then we're going to have negative distances and we're going to have positive distances. And so to avoid those canceling each other out, we square them. Okay. And so we square the values. We square the values. So we are only summing positive values. We are only summing positive values. Okay. What happens if you square a value? If you square 2, you get to 4, right? But if you double 2 and you consider 4 squared, all of a sudden you're at 16. Right, and so when we square values, we have this kind of parabolic shape. And if we're only thinking about, I guess we can talk about positive and negatives, right? But if we square the values, by squaring the values, we get this kind of shape, right? Kind of should be familiar with a parabola. Okay. And so what that means is, if I think about, okay, here's 2, then 2 squared is 4. But if I only move a distance of 2 here, let's kind of space these out because I didn't give myself very much space, right? Then all of a sudden, I'm way up here at 16, right? So a distance, oh, sorry, this distance is 2, 4, but the length is 2 is what I meant, sorry. Right? And so a distance that's twice as large is more than twice as bad, right? Instead of going from 4 to 8, right, now all of a sudden we go to from 4 to 16, right? And so the reason that we do it is because we see from that parabola, right, that a distance that's twice as large, right, or a deviation from an observation to the mean, a deviation that's twice as large is more than twice as bad, right? And so that's what we've captured by squaring things. We see that a deviation that is twice is as large is more than twice as bad. Okay, and that's reflected in the variability, the variance is what I meant to say. It's both true. So no harm, no foul. Okay, so that's kind of the logic behind this formula, right? Applying the formula by hand it's for the birds, it's not for us anymore, right? We're going to use software to do it, and of course we're going to calculate it in R, and then we're going to use Python, and then we're going to see that we get the exact same answers, right? So nothing crazy here, but the actual calculation is not for us to do by hand anymore. It's more the anatomy of the formula that I want you to focus on. So then the standard deviation is kind of the little brother of the variance, because then we just, if I want to go from s squared to s, what do? I can take the square root, and then I get the standard deviation. So the standard deviation lowercase s is the square root of the variance. Is the square root of the variance. Okay. Which means that the standard deviation is the square root of s squared, which means it's the square root of the sum from I equals 1 to n of xi minus x bar squared over n minus 1. Okay. We don't concern ourselves with the negative portion of the square root. We can't have negative spread, right? Spread is always positive, and so that's why I'm only considering the positive values. But remember, when you take the square root, you have to consider the positive and the negative, but in this case, the negative doesn't make sense, so that's why I'm forgetting about it. Okay. So this is a direct relative of the variance, and so the anatomy just stays the same, right? It's the distance of each observation from the mean, right? How far is it from the center? How far are things from the center? And then we square them to kind of amplify big distances, and then we add them up, and then we divide by n minus 1 again, because it gives us a better estimate, right? Kind of a better estimate. I wanted to think of a better word, but it's okay. So both the variance and the standard deviation are they're sensitive to outliers. I had to think of the word, which I had written down. Phew. So the variance and the standard deviation, as well as the mean, right? Those are all sensitive to outliers. So it makes sense because we're using the mean in our calculation. And so if the mean is sensitive to outliers, then of course the variance and the standard deviation will also be sensitive to outliers. So just like the mean the variance and standard deviation are sensitive to outliers, good. So just like we had kind of workarounds, right? We have the median, which is robust to outliers, meaning it can handle some outliers and it really is still a decent measure of center. We had the trimmed mean where we say, okay, well, what if we lob off these potentially extreme values, then what's our mean, right? We had options. And so same thing for the variance or the variability. We can have robust measures. However, the standard deviation and the variance are the most common measures of variability. Okay. And so note that the variance and standard deviation, and maybe I'll just say SD, just keep it nice and short. Note that the variance and standard deviation are still the most common measures of variability. So they're still the most common, but they do react to outliers, right? They're going to be kind of swayed by outliers. So there are other measures of spread we've talked about. So from Stat 230, we know the interquartile range is a measure of spread that we can use. And it is robust to outliers because it relies on just the quartiles. But another measure that we can talk about is the MAD, the mean absolute deviation. And so some other measures of variability we can consider are the mean absolute deviation, which we often call the MAD. Okay. Now the MAD is, it takes into account the distance from the mean, but then instead of squaring those deviations, right, those distances from the mean, we take the absolute value instead. So what that formula ends up looking like is very similar to the variance. It's the sum from I equals 1 to n of the absolute value of xi minus x bar divided by n. The absolute value, again, makes it easier because now we're not canceling out these positives and negatives, right? And so we can add these up and still have a sum of the deviations. And so here, right, the absolute value makes the deviations positive. Okay, but it doesn't change the magnitude. Unlike the squaring, if I square something, then something twice as large becomes more than twice as bad, right? And so, but maintains the magnitude. Maintains the magnitude. Okay. That's good and bad, right? It's good in the sense that, okay, we can still add these things up and we can still talk about how far things are from the center. But sometimes we want to incorporate that, okay, well, if things are really far away, then that's really bad, right? Then we have a lot of variability and we need that to be reflected. And also notice that it's the mean because we're adding them up and then dividing just by n as opposed to n-1, right? And it just has to do with biased estimates and unbiased estimates, which you're not expected to know anything about. Okay, so don't worry about that. But we're still talking about the distances from the mean. And then by the previous logic, if we're saying here, the distance from the mean, and then I take the absolute value, if the mean is sensitive to outliers, then my logic would say that the MAD would also be sensitive to outliers, but it's actually more robust to outliers than the variance and the standard deviation. Okay, and so the MAD is more robust to outliers than the variance or the standard deviation. Okay, and it's mostly because I'm not amplifying, right? I'm not making those distances larger, right? If I'm using a mean that's being pulled towards an outlier, right? And so the MAD is more robust to outliers than the variance or the standard deviation, since it does not amplify the deviations from the center, right, which might be pulled towards the outliers. The deviation, maybe I'll say deviations from the center, which might be pulled towards outliers, which might be pulled towards outliers. Okay. So it's all this kind of intertwined, you know, if the mean is being pulled towards outliers, which it will be, right, because it's not robust to outliers, then if I'm measuring deviations from the mean, but that mean is being pulled toward outliers, then it's not a robust measure of center anymore, right? But if I'm just looking at, you know, plain and simple the distances, and I'm taking the average distances, then that's going to be a little bit more robust, right? And so robust to outliers. We've already talked about, so you know about percentiles, specifically the quartiles, right? We've already talked about the quartiles and some other measures of variability that are more robust to outliers are things like the percentiles, the quartiles, the interquartile range. Okay, and so some other measures of variability that are robust to outliers include the percentiles. And maybe what I'll do is I'll bump this over and define the percentiles, right? The percentiles is the value where at least P% of the data is below that point, and 100 minus P% is above that point. And so the Pth percentile is a value such that at least P% of the values or maybe I'll say of the observations take on this value or less, take on this value or less, right? And 100 minus P% are above it. So here, P% below this value and 100 minus P% above this value. Sometimes people get tripped up because you want to talk about the top 1%. What's the top 1%? Well, that's the 99th percentile, right? So if we're talking about the first percentile, that's actually the lowest 1%, which we rarely want to talk about, right? And so just kind of make sure that that Pth percentile is the value below it, and then the 100 minus Pth percentile is the value above it. Okay, so the quartiles are just special percentiles, right? It's the 25th, the 50th, and the 75th percentile, right? So Q1 is the 25th percentile. Q2 is the median, which is the 50th percentile, right? Half the data below it, half the data above it. And then Q3 is the 75th percentile. Right, so we've talked mostly about quartiles in the past, and they're just special cases of the percentiles, but just know that you can talk about other percentiles. Right? We've talked about the interquartile range, right? The interquartile range is the IQR. Usually we just call it the IQR, and it's Q3 minus Q1, right? Referring to Q3 and Q1 here. So it's the distance between the first and the third quartile. So this is the distance between technically the 25th and the 75th percentile, right? But usually we just, so it's kind of this kind of chain reaction here, but as long as we know what percentiles are, we can kind of come back to this. So distance between the first and third quartile. How do you find the distance? Well, you take the largest value minus the smallest value, right? But usually that's the distance between the first and the third. So don't mix up the, there is no distance between the third and the first technically, right? You have to go from smallest to largest in the distance statement. But the distance between the first and the third quartile, or 25th and 75th percentile. Right, those are all saying the same thing. There are more measures of variability in the textbook, right? So see the textbook, and I'm going to do that more and more, is kind of point you in the direction of the textbook, because there are more, but we can't talk about all of them. Right, and so see the textbook. For other measures of variability. And because I'm using a free textbook, I mean, you can buy it for relatively cheap. But because I'm using a free textbook, I don't really, well, I guess I do feel bad because I'm mentioning it, but I do want to point you towards it, and I do want to use it because it's available to everyone. Okay. So there's lots of other measures of variability, but those are the core ones that I want to focus on for now. Okay. So what I want to kind of finish on is talking about exploring distributions. So the data distributions. Exploring the data distribution. We're going to focus on numerical data, but I'm not going to say that because some of these, not all of them except for the frequency table, but some of these apply to categorical data as well. So I just want to just be broad about it. But what are some of the ways that we can look at a distribution, right? How can we summarize a distribution of mostly, well, okay, fine. How would I have called this before? I would call it summarizing / visualizing, and I'll put in brackets numerical data. Okay. So what are some of the things that we have seen in the past? Well, we've seen histograms. All right, so we've seen histograms. And that's kind of where we said, okay, that's where our bread and butter is. If we need to visualize a numerical variable, then we're going to make a histogram, right? And from the histogram, we can describe the shape, the center, the spread, and that's where we're going to end up as well. And so, right, we can see the shape, the center, and the spread, right? So the shape is the only thing that we haven't really talked about again, but we did talk about the center or the location, and the spread, which is the variability, right? And so here, maybe I'll put location and variability. Okay. So we're familiar with histograms, so I'm going to parking lot that a little bit. But a histogram is just a visualization of a frequency table, right? And so if we have sorted our data, even numerical data, into bins, then we can summarize that in a table, right? We can always make numerical data categorical, even if just temporarily, right? And that's how we make histograms, is we put them into little bins. We put our measurements into little equally spaced bins. And so a frequency table is just a table that summarizes the histogram, right? It's what our histogram is based off of. So what we use to make our histogram, oops, right? It's a summary of all the counts in specified bins. Summary of the counts in specified bins. Right? And then we just visualize that with our histogram. So that's not very interesting. I prefer a histogram over a frequency table for, and I think I know I'm not alone in this. When I look at a table of numbers, it's hard for my brain to kind of think about magnitude, right? Comparing those counts, those raw counts, is really hard. So often we convert them to proportions, right? Or percentages if we prefer. And so we've got ways around that, but I think a histogram is just easier to look at, especially if we have numerical data. We can also consider a density plot, which is kind of like a smoothed out histogram, which we haven't talked about in the past, but it is just a smoothed out histogram. It uses some kind of estimates that we're going to ignore, but it's what we call a density plot, which we haven't seen before, but it's all we need to know really for now is that it's a smoothed out histogram. Okay. And then finally, because I know I'm running low on time here, is we have a box plot. A box plot also helps us visualize the distribution, right? Because what do we have? If we have our kind of number scale here, there's nothing really happening on the x-axis, but we do have these components. So we start with the box, hence the box plot. We've got the central value, which is the median. So here I've got my Q1, I've got my Q3, and then I've got my median denoted by a thick line in the center. And sometimes we'll throw the mean on there, but it's not part of the box plot. It's just to help us visualize. And then we've got whiskers, right? We've got these whiskers and potentially some outliers. The whiskers, and let me see if I can find a different color here. The whiskers extend and use the 1.5 IQR rule, right? And so here, the outliers and the whiskers rely on the 1.5 IQR rule, right? And I'm all out of time, so you'll have to brush up on that on your own. But R uses the 1.5 IQR rule, and it is the most common one that we use. But you might find software where it uses 2 times the interquartile range, but they typically rely on the interquartile range. Anyways, so we'll keep working through chapter 1 next day. And if you have any questions, let me know. Otherwise, I'll see you on Thursday. I'll stop this here.